Okay. I will start. Yep. Okay. If you don't understand something, then raise your hand immediately. And any other questions or comments, please only at the end. So make notes if you need to. Since I'm under time constraint, I will skip the first preliminary slides and go right into the meat. Okay, what is unusable exactly? Grammar parsers have a documentation problem. Very often they do not tell the programmer who wants to use such a library which type of parser or algorithm the library uses under the hood, or at the very least mentions the limitations. There's at least one grammar parser documentation that outright lies to the programmer. If the programmer wants to determine whether the library is suitable for his purposes, instead of deciding upfront, he has no choice but to try out the software. Multiply this by every programmer who tries out the software. This is a colossal waste of time. There's another problem. Sometimes the programmer not only parses input under his control, but passes the parser off to an end user. The end user supplies input unforeseen by the programmer and the parser breaks. Sometimes it turns out that the grammar was not quite correct, and the programmer can amend the grammar. However, sometimes the grammar already was correct, and the flaw is inherent to the parser's algorithm, but the flaw exhibits only under certain input, and so there's nothing the programmer can do to fix it, except to switch over to a different parser that does not have the algorithmic flaw. Again, this is a waste of time. A programmer should be able to make an informed decision which grammar parser is good to use, but the information is incomplete. The goal of the project Grammar Shootout is to make up for the shortcomings in the grammar parser documentations, in order to save the interested programmer some time. This is achieved not by amending the various documentations, but by torturing parsers with all kinds of grammars and a multitude of valid inputs and comparing the results. A programmer can then easily pick up a grammar parser that passes the tests flawlessly. He can be much more confident that the parser will not break later. In fact, there are grammar parsers whose algorithm is proven to accept any context-free grammar. That is to say, that the grammar parser is free of algorithmic limitations. It is very desirable to know which grammar parsers are in this category. If one has the choice to pick up a grammar parser for a new project, why would one ever pick a flawed one? And for already existing software that contains a parser, the test results show scenarios where a grammar parser might break, and the programmer can be proactive about the problem without urgency, instead of being confronted out of the blue by a bug report from an end user. The documentation might mention the limitations in an abstract way that would be difficult to understand for some programmers. The comparison shows problems in the concrete, which aids to understand them more easily. And lastly, this comparison also functions as a survey of the various APIs of the grammar parsers. By inspecting the generated code, a programmer can get a feel how much effort it is to put a grammar to use with a certain grammar parser. My personal opinion is that software should reflect the motto, easy things easy, hard things possible. It should be straightforward to get going with simple parsing tasks, yet the software should be powerful enough to solve the most difficult parsing tasks. Grammar parsers that have an unwieldy API for no good reason or needlessly expose complexity to the programmer score badly in my mind. And here's a current comparison of parsers. Antler and Peg.js are written in JavaScript. Per6 grammars are of course in Per6, and the other ones are Per5 libraries. There are currently over 60 grammars, and each grammar has up to 30 valid inputs. And if the correct result comes, of course, it gets a green check mark, otherwise a red X. So this is the whole thing at once, and I will zoom out so you can get the general feel. So let's have a look again at the columns. And one can see that Per6 grammars score badly. Problems with Per6 grammars and similar. Per6 grammars can do many things, but not particularly well. What does that mean? I have picked representative features that one can find only rarely in other grammar parsers or not at all. Usually there are only Claney Plus installed at the most. But Perl-6 grammars also have these operators and assertions, like known from regex engines. Some problems I'm addressing are due to the algorithm, some are specific to the implementation. Anonymous terminals do not automatically become part of the tree. If you want to know, we want to pass this kind of text, and we expect a digit, then either a plus or a minus, and then again a digit. This will return you the 3, the 4, but not the thing in between. Left recursive rules create an endless loop. The bug exists since beginning, is reported since 2 years on RT, but has not been addressed yet. I also wanted to know what the parser is under the hood or its limitations. That is nowhere in the documentation. After 2 years of silence on RT, no one could tell me. Moritz even managed to write a 200-page book about the topic without saying what is the matter, of course. It is not anticipated to influence the return value. One can only mangle it after the tree has been completely constructed. There is a magic method called match in all capitals, but it is not documented on purpose. Actions, whether intrinsic or in a class, do not help. Everything has to be done by means of the magic $/ variable. The return statement is ignored. This is a daft design. Other programming languages break their bones in order to inhibit assignments to global variables, but Perl-6 does not care two hoots about it. Perl-6 implementers have a motto: we torture ourselves on behalf of the end user, so that his programming is comfortable. Commonly this is true, but in this part of the implementation they did not cover themselves in glory. Ambiguous parsers are forcibly resolved over the head of the programmer, and if that was not the desired return value or does not fit the desired semantics, then you're out of luck. The documentation names an incomplete convolute of rules, which in turn points to a document S05, which says about itself that it might be out of date. In any case, S05 describes how to force a certain result. And if the programmer does not like that, then there's no way to influence it, and there's also no documentation how one might be able to achieve that. That makes the parser generally unusable for parsing natural languages. For example, it is not possible to parse the following sentence with Perl-6 grammars. This is a typical example from the standard literature. Okay, the sentence is at the bottom. You can't. Most of you won't be able to see it. It says, "I saw the man with a telescope." Here again, this is the grammar description, and it contains the words. And there are two possible ways how to parse the sentence into the constituent sentence parts into a tree. To make it short, the telescope might belong to I or me, or to the man. And then there's the problem of not being able to confidently intuit how much Perl-6 grammars consume, or if at all. Here are 3 examples that look trivial but are quite crafty. Here's a grammar definition with only one rule. So what does this rule produce? So we know there's an A at the end, and then before this is either a single A or a double A. So the first production would be 1A followed by an A, here, 2 A's, or 2 A's followed by 1 A makes 3 A's. Simple. So this is quite nearly the same thing, only that the order is switched around. So again, 2 A's followed by 1 A, which is this production, or 1 A followed by 1 A, which is this production. And rule which contains itself, refers to itself. So let's have a look at the right side of the alternation first. So the first production would be 2 A's here. And then we might use this result, put it in here. So we have 2 A's flanked on either side by 1 A, makes 1, 2, 3, 4 altogether. Then we take these 4 again, add 2 A's, so we get 6 A's, and so on and so on. So the productions are an even number of A's. Okay, so far so good. So let's see how Perl-6 deals with that. If we translate the rule to the grammar syntax, then we will get, then it will be able to parse 2 A's, but not 3 A's. And again, if we switch it around, then it will be able to parse 3 A's but not 2 A's. And for the last example, let's make it a bit smaller. So we can see it parses 2, 4, but not 6, then 8, but not 10, not 12, not 14, but 16. So do you realize the numbers, these are powers of 2, which is neat, but wrong. So now this is all still reasonable if one sits alone and works on a Perl-6 grammar and develops it oneself step by step, and runs tests with each change described in the textbook chapter 7.5, so that one can notice immediately if something breaks. This way one can keep track. And but the reality, of course, looks different. One gets code from someone else put in front of oneself, and the number of elements in a realistic Perl-6 grammar are orders of magnitude larger. And if one wants to change or expand it, and then it expands because one cannot recognize or comprehend what the parser is doing by merely looking at it. And if you think this is not a likely scenario, then be reminded that this is an explicit feature in the design. The keyword grammar acts like the keyword class. That is to say, it is anticipated that one derives from Perl-6 grammars by means of inheritance, etc. And indeed, one of the S05 rules I mentioned earlier is a subject of how to deal with inherited methods. One cannot parse binary input blobs. When I asked about it, the ticket got marked simply not yet implemented. So it might come eventually. But right now you can't. You need to use a workaround to achieve that. And one cannot parse sequences. The input must be completely loaded, must be first completely loaded into memory, and this ruins the laziness of your program. And when push comes to shove, developers show the white feather. They are not confident in the software and do not use it themselves. Every interesting parsing problem in the interest sphere of Perl-6 uses ad hoc parsers instead of Perl-6 grammars. The exemption is the module UI. Now the situation is quite frustrating, especially owing to the silence on RT, and it is not acceptable that interested programmers are losing time to faulty software. Or imagine a newcomer who watches Andrew's parsing video on YouTube and thinks, hey, cool programming language with an easy-to-use parser, let me try that. And then only after a few days it breaks. Now this is a shabby first impression one never forgets again. And so it is overdue that somebody finally sits down and writes a reasonable parser. It can't be that difficult. So I did. So the table of tests for this parser is green. This means that the parser accepts all grammars, unlike the other parsers which bomb out. It is free of limitations. All parts of the grammar definition become automatically part of the return value. It processes all grammar definitions without problems. Left recursive, right recursive does not matter. It parses natural language without problem. If there are several possible results, one gets all of them, not only one arbitrarily. Any intuition about how an input is processed is also adhered to. Stupid replace and rewrite matches exactly the internal processing. There are no global variables, and neither there are assignments to global variables. Yes?
What type of parser is it? Is it like a
No. The type of parser is called Erlay.
Oh, okay.
But this is not the algorithm that was published back in the 1960s, but it has some improvements on top of it. This is the state of the art what we can have now.
Do you have references at the end? Do you know them?
Yeah, the references are already published on CPAN in the MARPA module.
Okay.
Google MARPA bibliography, and then you will find all the papers. Where was I? Yeah. Return values. Return values can be adjusted with a simple callback. This happens at parsing time, not after the tree is constructed. It processes infinitely large inputs. It processes binary inputs, and there's no subterfuge through backtracking. The software is not production ready, so I invite you to help with it, and there are still lots of things to do. But the most difficult part is already done. The source code is on GitHub. And I'm at the end. Time for your questions and comments. Yes, again.
Yeah, I have no experience with markup.
Mm-hmm.
It's a bit surprising that it fails so often, because if you read in the webpage, it says that it's like the best thing ever.
Yeah.
So, right. So why do you think that's the case?
Yeah, these are not.
Please repeat the question.
Yes. Why is MARPA so red? In short.
Yeah.
Well, these are not real failures, but I can click on this button and then we'll see what is going on. So these comparisons fail all for the same reason, namely here. For example, we expect that this rule contains a null result, but MARPA by default cuts out all A's. So this is just all nulls. Sorry, this is just an artifact of me doing this comparison as a string-wise comparison. So I asked the author, hey, can you offer me an API to skip this post-processing, that the nulls stay there where they are? But it was not successful. So if you know how to do this, send me a patch. Then MARPA will, at least for these tests, also be fully green. Now, since it is so difficult to get code out of the author, I decided to write my own implementation, and that was a good thing to do, because now we have 450 lines of PerlCon code instead of 90,000 lines of C code, and I have features that MARPA does not have, like processing of infinite inputs. 2 more minutes. Yes, question.
First of all, thank you. Cool talk.
Yeah.
Second, the example with the A's and alternation. I noticed you were using double pipes. Does the answer change if you use single pipes?
Yes, the question was in this example here. Does the answer change if I use a different alternation operator instead of double pipe, a single pipe? Yes, it will change around. So again, then it will say here not okay and here okay, and here okay and here not okay. So, but what I expect is, of course, that all are that all of them are parsed. Yeah.
Expected it to be more correct.
We can try later, and then let's see. Yeah. A last one. No? Okay. Yeah, then thank you for your attention, and I'm still available in the coffee break.